This separation technique is going to be distillation. So the first thing I'm going to do is I'm going to make my solution by getting some water and dissolving some table salt, sodium chloride, into it. That's probably more than will dissolve, but that's okay. I'm just going to stir that up. And then I'm going to transfer it into a bigger beaker, and that's partially so that any salt that's left on the bottom of my small beaker doesn't get in the way of trying to actually separate the solution. So there's my solution, and now we're going to put it on the ring stand, and I have a second ring here in case the thing gets boiling and wobbling around and we don't want the beaker to fall off and smash. So this is for extra security. So now I'm going to get my Bunsen burner going. There we go. Whoops, try again. Okay. That's a bit much. We'll turn the gas down there. And now we wait for it to boil. Okay, and as you can see, the solution is bubbling away, it's boiling, the water is evaporating off, and in a few more minutes we should be able to get our results. So the distillation is almost done, and I'm not real sure if you can see it on the camera, but they're starting to form some salt crystals up here where the water line used to be. The water is almost all boiled off, so we're just going to let it be for a few more seconds. And when it's almost done, I'll turn the gas off. I have my heat gloves and my beaker tongs, because remember that one of our safety rules is that hot glass looks the same as cold glass, and so we want to make sure that we don't burn ourselves when we can't tell the temperature of the glass. Now this technique will be effective, this experimental setup will be effective if what you want back is the salt. If what you want back is the water, well, that is going to be an environmental science challenge coming up after the holiday break. I can tell by the noise and the color that the distillation is almost done. All the water is almost all boiled off. So I'm going to go ahead and turn the gas off and give it a moment to stop boiling. Still really hot. There is all of the salt back. So we have successfully distilled off the water and left the dissolved solid behind. And now I'm going to leave it on the counter to cool. And they're not very pretty crystals, they're really small. If you want large crystals that allow you to help identify the substance, then what you want to do instead of distillation is crystallization. This separation technique is filtration. So first I have to get my filter paper from my favorite brand of filter paper, and it's a circle, and we're going to fold it in half like a taco. Then we're going to fold it in half again like this, and there are 4 sections of the paper now, and so we're going to grab 3 of them on one side and one on the other side. And what it does is it makes a cone that doesn't really have any spaces in it so that you can filter. Then we're going to get an Erlenmeyer flask and a filter funnel. And we're going to use a little bit of distilled water to stick the paper filter to the filter funnel. Now I'm going to make my mixture, which is just some sandbox sand. I'm going to put some water in it. And I'm going to stir it all up. Make it nice and cloudy. And that's pretty gross. But with our filter, which has tiny little pores in it, and it takes time, the water, there it goes, is going to drip out clean, and all of the solids are going to get trapped in the filter. So even though I have not filtered all of the mixture that I made, the first part of filtration is done enough. There is the pretty much clear water. Here, let me hold it up against some white so it's easier to see against white instead of black. So I recaptured the water, and inside the funnel is all of the dirt or sand. And so if I actually take this out and unwrap it, it's still a little wet, but you can see all of the recaptured sand right there on the filter. If this were not science water, yeah, you'd probably be able to drink that. In this flask is a supersaturated solution of sodium acetate. That's a lot of sounds. Sodium acetate is actually the chemical that is a product when you mix vinegar and baking soda. I have it in convenient powdered form here in my chemistry supplies. Now I made this supersaturated solution by mixing 160 grams of solid sodium acetate with 30 milliliters of water. Of course it didn't dissolve. It's way too much solid, and so I heated it up on the hot plate and used the stir bar to get it to all dissolve, and then I let it cool. This mixture is so saturated that only a tiny little bit of agitation to it will cause it to solidify. So I put a little bit of crystals, they're called seed crystals, on sodium acetate on this plate, and with any luck this demonstration will work when I pour it out, and there we go. Perfect. Look at that. It's solidified so well that it blocked the rest of the sodium acetate from pouring out of my beaker, but it's solidifying now in the beaker. Sorry, flask. The other thing is that it's warm. It's warm. This demonstration is sometimes called hot ice. The flask is heating up. The glass dish is heating up. And sometimes this material is used to make hand warmers. Now, one of the great things about the sodium acetate recrystallization from a supersaturated solution is that being a mixture, being a physical reaction and not a chemical reaction, is that all I have to do is stuff all of this solid sodium acetate back into the flask, remelt it, and I can do the demonstration over and over and over again. I've been using this same sample of sodium acetate for many, many years. Our next separation technique is chromatography. We're going to be doing some wet erase marker chromatography. And the chromatography paper that we're going to use is super fancy science equipment, coffee filters. So the first thing I'm going to do is use my pencil to write the name of my marker on the edge of the coffee filter. And I'm using pencil because if the technique works the way it's supposed to, it would make your pen ink run all over the coffee filter. And so that is why I'm using pencil instead. The next thing that I'm going to do is I'm going to make about a penny-sized circle in the middle of my coffee filter of each marker. Some of my markers work better than others, and I'm just going to fill in the marker spot as best I can. And now I'm going to see if I can get that School Smart one to work a little bit better. These are my worst wet erase markers. They're called School Smart, but they're not very. Okay, then I'm going to use my pencil or something else sharp to poke a small little hole in the center of my black marker spot. Can't really see it, but it's there. And I'm going to do that for each one. You can see it better on that one. Then I'm going to get another coffee filter, and I'm going to kind of tear it into like 3 sections. And what I'm going to do with each of those sections is I'm going to roll it into a wick to suck up some water. So one end can stay really flared and open, but the other end you're going to roll up really, really pointy. And you're going to put it through the hole that you made. Oh, need that to be a little bit tighter. There we go. Through the hole that you made into the center of your marker spot. So now I have the wicks ready for all 3 of the markers that I'm using. And I'm simply going to get any cup, doesn't really matter which one, and I'm going to fill it about halfway with water. Enough water that the big coffee filter that has your marker on isn't sitting in the water, but that the bottom of the wick is. And I'm just simply gonna place them in the water. And the water will travel up the wick and then hopefully cause the marker ink to spread out. And we'll check back later. So it's been about 15 minutes, so let's check on our chromatography. And there we go. You can see that the water is causing the marker colors to spread out across the coffee filter. And some of them are working better than others, and that's okay. That's partially because of the brand of marker, but also partially because of the quality of my coloring. We're going to leave them even longer and see if they spread out more. I gave you guys 2 different markers than these 3, so we should have 5 results altogether that we can compare to see the components that go into the mixture of black ink. So this chromatography has been going for about an hour, and so it might be as good as it's going to get. I'm just going to pull the wick out. This one is this marker, and you can see the colors all spread out. I'll take a separate picture of it in a little bit. This one is the School Smart marker, which very interestingly seems to have come out the best out of my current chromatographies. And then this is a new brand that I tried, and this is what it looks like so far. And I'm going to leave this one for a little bit longer, and then I'll take a picture of all 3 of them when they are done, and then we'll be able to compare them to this marker, which is one of the ones that you guys are going to do, as well as this marker, which is the other one that you guys are going to do. And then we'll see how black ink is made.